It's playtime, baby. Let's look at this. It says, I'm going to give you one trigonometric ratio. I'm going to give you one of them. And I'm going to tell you exactly where this guy is. Do you realize from this one trigonometric ratio, I can figure out the exact values of all of the remaining trigonometric ratios? This is freaky. Wait, I'm going to show you how it's done. Here's a question right here. It says, I got cosine. And this is going to be the cosine is going to be root 5 over 4. But do you remember what cosine means? Cosine of theta is adjacent over the hypotenuse. So in other words, I just gave you the adjacent, I just gave you the hypotenuse. This obviously right here, there's the AGJ. This here, there's your hypotenuse. Oh my. Right. But I also gave you a condition. I told you that that angle has to be between 3 pi over 2 and 2 pi. Oh boy. That means, okay, wait a second. Where's 3 pi over 2? Right? Well, wait a second. I know pi over 2's means I'm going to be dealing with this guy. There's pi over 2. There's 2 pi over 2, which is pi. Guess what? 3 pi over 2's got to be here. And 2 pi is, yes, you got it. It's right here. So I'm looking specifically at this quadrant. That's what I'm looking at. Ah, the rest of these quadrants I don't care about. I'm looking at this quadrant. That's what this restriction tells me. Oh, interesting. Okay, now let's draw any kind of angle out here. Any kind of angle. I'm just going to draw a standard. I'm not sure what the angle is going to be, but I know that that's going to be my reference angle right here. Okay, that also means that this pattern is now like this. Why? There's my positive x value. There's my negative y value. And look at this. I just told that my adjacent is root 5. So according to this angle, this must be my adjacent right here. And that value is root 5. This is my hypotenuse. Okay, so there's my hypotenuse. I can find out this value, couldn't I? A squared plus b squared equals c squared, baby. You learned this all the way back in grade 8. Right, so here we go. A squared is root 5 squared plus b squared equals to c squared, which is 4 squared. This is going to mean that this is b squared equals to 4 squared minus root 5 all squared. And figuring this out, oh, that's easy enough. B squared equals to 16 minus 5. So that's going to be 11. So b then is root 11. But wait. You know, since it's down here, that's got to be negative. So this, in fact, has to be negative root 11 because you're going down. That changes everything. Now that you got this, well, all the trigonometric ratios are easy based on this wonderful little triangle that you drew. So let's write out the trigonometric ratios. There you go. All right. So what is sine? Sine is got to be opposite over hypotenuse. So you're looking at negative root 11 over 4, right? The next one is going to be cosine, which we already know, which is root 5 over 4, because that was given in the question. Root 5 over 4. Tangent, opposite over adjacent. Okay, so this is negative root 11 over 5. Look at that. Now, the cosecant and the secant and cotangent are all just reciprocals of that. But wait a second. Let's make sure that we're on the right track by putting in our CAST rule. Add sugar to coffee. So is our cosine positive? It is. Is everybody else negative? They are. We're doing the right thing. Oh, hallelujah. Okay, so let's do our cosecant. Cosecant is opposite of sine, so this is going to be 4 over root 11. Remember, it was negative. Okay, again, you're going to have to clean up that denominator. That's important. Multiply by root 11, multiply by root 11. This is negative 4 root 11 over 11. Oh boy, that's really tough. Flip this guy. Okay, the flip of this guy is going to be 4 over root 5. Again, multiply by root 5, multiply by root 5. This is going to be 4 root 5 over 5, and that, in fact, is positive. Cotangent, flip it. This is going to be, right, negative 5 over root 11. Okay, again, multiply by root 11, multiply by root 11, you get negative 5 root 11 over 11. Look, from one trigonometric ratio, I figured out all of them, all 6 of them, just by that. So cool.